Hi everyone. This is a video on what we call the empirical rule. And what we're going to do now is take a look at a little bit of data. Imagine that I have two dice um, and I roll them. And I think most of you can know what two dice are. You know, they've got the six-sided. When you play games, there's a side with one, a side with two, side with 3, 4, 5, and 6, and so on. And so when you have two of them, you roll them. And let's say I roll them a bunch of times and I record what I get each time, and I record it on a dot plot. So, and this is the results of those tosses. And this is a highly unlikely outcome, but let's say I roll the die 37 times and my results turn out to be perfectly uniform. So I get a 2, which means snake eyes, a 1 and a 1 on each die, and I get a 2 one time. And so on. I roll a 3 two times, and so on. And let me, oops, let's put that back on. And these are the results, okay? So I put them all here. I get the 2 one time, a 3 two times, so on. And when I add all of those up, I end up with 37, or in other words, that's also equal to n. That's how many times I roll the die. So I have 37 data points. And if we look at this, I did this on purpose. This is perfectly symmetrical outcome, or as you remember, the normal distribution. And because this is normally distributed, we're going to take a look at the mean and the standard deviation. So if you punch all of that into your calculator, or do it by hand, which I hope you don't, you're going to discover that you end up with a mean of 7 and a standard deviation of 2.4. Okay, so let's take a look at what that means. So here's my mean right here at 7, which is to be expected. Center right here at mean. And then we have one standard deviation is equal to 2.4 points, or whatever you want to call those dots on the die. Okay, so let me draw in one standard deviation. What would that be about? So x. Let's start here. Let's take a look at the typical value. Typical value. What can be expected of me if I roll two die? And as you remember, that was the standard deviation. I'm sorry. I apologize. It is the mean plus or minus one standard deviation. Okay. So in this problem, our mean is 7, and if we add one standard deviation of 2.4, it equals 9.4. Now, of course, we can't roll a 9.4, but this is roughly where one standard deviation lies. And so here is 9.4, right about here, 9.4. And if I'm just going to draw a line right here, and this was that hat plot that we would make, right? And if I do on the other side, 7 minus that 2.4, we end up getting 4.6 for that lower boundary. And I'm just going to plot that as best I can. So here's 0.4. 4.6 is right about here. So, yep, there we go. Right about there. And so here's kind of our plot. Here's kind of our box. This is our typical range right in here. We can expect to roll anywhere from a 4.6 to a 9.4. And so what if we were to do that an infinite number of times? Well, it turns out, in what we call the empirical rule, is that in fact the percentage of time that we will be within one standard deviation, 4.6, it turns out to be 68% of the time. 68% of the time we will roll between a 4.6 and a 9.4, right? Within one standard deviation. That is what we call the empirical rule. And we'll talk about where that 68% comes from in a later video, but right now we need to sort of accept that. If we add a second standard deviation, so for example, if we take our mean, which is our mean, and we add plus or minus 2 standard deviations, what happens then? Well, what that means is 9.4 plus another standard deviation, or 7 plus 2 times 2 standard deviations, 2 of those. So in other words, 4.8. We're going to get 11.8. We're going to be way out here at 11.8. 11.8. And this distance, this is a second standard deviation. So from here to here, from the mean all the way out to here is now 2 standard deviations away. Okay, and if we do the same thing on the other side, we are at 2.2. Oh, that keeps happening. So here's 2 standard deviations below. All right, if we take a look at this area in here, that is going to be 95%. 95% of the time we will be within 2 standard deviations. 68% of the time our data will lie within 1 standard deviation, and 95% of the time it will lie within 2 standard deviations. And then when we talk about 2 standard deviations, this is anything outside of 2 standard deviations becomes unusual. Outside of this, outside 2 standard deviations. And why is that unusual? Because it's what we call the 5% rule. So 5% of our data is going to lie, let me get another color here, 5% of our data is going to lie outside of these 2 standard deviations. 2.5% on this side and 2.5% on this side. And that's a very unlikely. So if I were to roll the die a 38th time, it would be very unusual that I would roll less than a 2.2, which in this case is a 2, and it would be very unlikely for me to roll a 12, because the only number that's actually above 11.8 is a 12, the only number below. So it would be very unusual for me to roll a 2 or a 12. Anything inside of that would not be considered what we call in statistics the term unusual. Okay, so summarizing the empirical rule. Here we go. When our data is symmetrically distributed or normally distributed, as we have here, then our mean will always lie right in the center. And 68% of the time, or 68% of our data, will lie within 1 standard deviation. This is what is known as, which we've already talked about, the typical value. Typical value. 95% will lie within 2 standard deviations. And this area, this 2 standard deviations, 2 above and 2 below, is what we call our usual values. So slightly different. It may not be as likely, but it's still within the usual range. And then finally, within 3 standard deviations, we have 99% of our data, 99.7% will lie within 3 standard deviations. Anything beyond that, and I didn't draw this very accurately, the chances of it happening starts to get so small that it's negligible. And in fact, like I said on the previous page, anything outside of 2 standard deviations, I should put that in pink, sorry. Anything outside of 2 standard deviations is already unusual or unlikely. And this data here, all this pink shaded area only amounts to a total of 5%. Anything outside, anything that has a less than 5% chance of happening is unusual. Okay, and that's the empirical rule.